Hello there. Welcome to your very first video lesson of the year, and today we are going to go over slope and graphing lines. So, what is slope? Slope is also called the gradient, the incline, and the pitch, and it's used to describe the measurement of the steepness of a straight line or line segment. So for instance, the steepness of this roof right here. The higher the slope, the steeper the line. The slope of a line is also called the rate of change. Slope is important in many real-world situations. For example, a wheelchair ramp must be built so that its grade or steepness is small enough that a person in a wheelchair is capable of going up the ramp on his or her own. In addition, roads along mountainsides are designed with a small grade so that trucks do not drive out of control. If this happens, the positive slope of the mountain can assist in slowing a truck down along an escape ramp. The mathematical symbol for slope is an m, so anytime you are calculating the slope, you will start your calculations with the letter m. The formula for slope is the rise divided by the run. The rise is the vertical distance of the line segment, and the run is the horizontal distance of the line segment. When you make a triangle between the line segment, the rise, and the run, it's called the rate triangle. So let's see how this works in an example. So you have two ski hills, Hill A and Hill B. We're going to calculate and compare the slopes of the ski hills to determine which is steeper. So for Hill A, whenever you start calculating the slope, you're going to start with the letter m because that designates slope. It's the rise over the run, which is equal to, this is the rise because it's the vertical distance. This is the run because it's the horizontal distance. So it's 100 over 300. And in lowest terms, that's 1 over 3. For Hill B, the rise is 300 and the run is 800. So the slope is 300 divided by 800. And in lowest terms, that's 3 over 8. Always put your slopes into lowest terms. Which of these is steeper? Well, 3/8 is bigger than 1/8, so Hill B is steeper. So you're going to state which is steeper, but you also have to state why. Because its slope is larger. So that's your basic example of slope. Now, your equation for slope we just learned was rise over run. But there's a couple of other ways of writing the slope. So if this is one point here, and this is another point here, this point we might call it x1, y1, and this point we can call x2, y2. Then the rise here is going to be found by subtracting this y value from this y value. So if this point was 6, or a y value of 6, and this point had a y value of 2, then the rise went from 2 up to 6. So the rise is equal to y2 minus y1. The run is done along the x-axis. So if this x value was 1 and this x value was 5, the run would go from 1 to 5. So 5 subtract 1 would be 4. So that would be equal to x2 minus x1. So another way of writing the slope is y2 minus y1 over x2 minus x1. The third way of writing the slope is to use this symbol here. That is called delta, and it looks like a triangle, but it's actually a Greek letter called delta, and it means the difference. And difference means to subtract. So basically subtract your y values to get your rise, and subtract your x values to get your run. So let's look at some examples when you only have the coordinates. So for question A, the slope is equal to y2 minus y1 over x2 minus x1. So for this question, this is x1, this is y1, this point, first point. Second point is x2, y2. So y2 minus y1 is negative 4 minus 4. x2 minus x1 is 2 minus negative 4. That works out to negative 4 minus 4 is negative 8. 2 minus negative 4 is 6. And in lowest terms, that's negative 4 over 3. Always put your answer into lowest terms. Try that again using example B. So the first point is x1, y1. The second point is x2, y2. So to calculate the slope, y2 minus y1 over x2 minus x1, we have negative 3 minus 2 over 0 minus negative 1, which is negative 5 over 1. And to put that into lowest terms, that's just negative 5. So what I'm going to get you to do is to pause the video and try examples C and D on your own, and then press play back on the video to check your answers. So please press pause now and try examples C and D. Okay, welcome back to the video. If you want to check your answers to C and D, so for question C, y2 minus y1 was negative 10, x2 minus x1 was 4, lowest terms is negative 5 over 2. For question D, y2 minus y1 was equal to 6, x2 minus x1 was equal to 8, and in lowest terms 3 over 4. So this is all review of slope that you did in grade 9. If there's anything you don't understand, please make sure that you make note of it and ask your teacher in class tomorrow. The next thing I want to go over is some properties of slope. If your line is rising from left to right, then your slope is positive. If your line is falling from left to right, then your slope is negative. If your line is horizontal, then your slope is 0. And if your line is vertical, then we say the slope is undefined. In this case, if the line is vertical, it means there is no way that you can calculate the run. You can calculate the rise, but you can't calculate the run, and which would make the run 0, and since that's on the denominator of the fraction, you can't divide by 0. The next thing is parallel and perpendicular lines. The slopes of parallel lines are equal, and the slopes of perpendicular lines are opposite reciprocals. Opposite meaning they have the opposite sign, positive or negative. Reciprocals means you flip them upside down. So in this case, line segment J has a slope of 3 over 2. So if you have line segment K, which is parallel to J, its slope is going to be equal, which is 2/3. And if line L is perpendicular to J, its slope, we have to do the opposite reciprocal, which means you have to change the sign. So this is positive, you're going to change it to negative, and you're going to flip it upside down. Instead of 2 over 3, it's going to be 3 over 2. Line segment M has a slope of 2. When it's just a number, it means your rise is 2 and your run is 1. So what would the slope of a line parallel to this line be? That would be 2, because it would be equal. What would the slope of a line perpendicular be? Well, this is positive, so the opposite would be negative, and you'd flip this upside down. 2 over 1 would become 1 over 2. Last one, line segment P has a slope of 0. That means the line is vertical. So the slope of a parallel line would also be 0. The slope of a perpendicular line, well, the line that's perpendicular to a horizontal line is a vertical line. So that means its slope would be undefined. So that concludes the first part of your first day, which is reviewing slope. That was part 1 of today's videos. Please make sure that you watch part 2, which is the video on graphing line segments. So there are 2 parts to today. You just finished the slope video. Now you have to watch the graphing line segments video. So don't forget to watch the second part of today's video. Thank you.